All right, so let's just do some problems together. So I'm looking at this, what to do. So I see ln, seems to be I did integration by parts when I had ln of x inside. So I let u equal the function I know how to take the derivative of, and dv equal the rest. So v equal x, so du is 1 over x plus 1 dx. All right, so let's put it together. So you know integration by parts. uv minus the integral of v du. Okay, I always like to rewrite things because it sometimes helps me to see what's going on. So I have x over x plus 1. So I have options here. So this degree of the numerator is not smaller than the degree of the denominator. So I could go do long division, or I could do my plus 1 minus 1 trick. Add 1 and subtract 1. I like doing that. So I'm going to add 1 and subtract 1 in the numerator. And then I'm going to split around this negative. So keep this negative out in the front, right? So I've got x plus 1 over x plus 1, which will be 1 minus 1 over x plus 1 dx. Okay, so x ln of x plus 1. So then subtract, take the antiderivative of 1, which is x. Take the antiderivative of this, which is going to be ln of x plus 1 plus a c. And just because that big thing's in the way, I'm just going to rewrite it. So I get minus x plus ln of x plus 1. Need absolute value bars around that, right? Plus c. All right, looking at this one here, I can see that I've got a number inside the angle. So I am motivated to do what I just called my w substitution. So I have 1/3, and I'm rewriting this thing in w's. Okay, oops, let's make that a little neater. W in here. Okay, so now I'm thinking about my tan secant combination. I want to leave even powers. So this one here, I am going to peel off a secant and a tangent. So that would give me 4/5. So secant w, tangent w, dw. I do believe this is one of them that would work either way. So maybe I'll even do it the other way. All right, so this is my du. So secant w, tan w, dw. So my u would be secant of w. Okay, so that would be taken care of. This would be taken care of with my du. So it's this that I need to worry about changing to secants. So I know tangent squared, right, gives me tangent to the 4th. So tangent squared. So let me just write it out one more time. Tangent w, dw. Okay, so let's replace this with secant squared w minus 1. Carrying all this along. Okay, so now let's do the substitution. So I'd get the number 1/3 in here. I'd get u squared minus 1 squared. This gives me a u to the 5th, and there's my du. So I'd need to multiply this out. So I'd get u to the 4th minus 2u squared plus 1 times u to the 5th. And let's multiply here, so I get u to the 9th, 2u to the 7th, plus u to the 5th. And then finally take the antiderivative, right? U to the 10th minus 2/8, u to the 8th, plus 1/6 u to the 6 plus c, and then I would put my secant back in, right, for each of these, and then I would put the w of the 3x back in. So let's just write one more step here. So I would get secant to the 10th of 3x minus 1/4 secant to the 8th of 3/8 minus 1/6 secant to the 6 of 3x plus c. All right, so I do believe this is one that will work the other way as well. So let me just do it up here. You've already written this one out. Okay. Of course, it's not making it easy for me all of a sudden. Okay, so after I do this w substitution, so let's peel off tangent to the 5th, I'll leave, keep my w, and I'll peel off, so I'll have secant to the 4th w, secant squared w dw. So this would be my du. My du would be secant squared w dw. So my u would be tangent w. So this would be taken care of. This I would need to change. So 1/3 tangent to the 5th of w. So I would rewrite secant to the 4th as secant squared squared. And secant squared is tangent squared w plus 1. And then secant w. All right, so now let's do the u's. So I get u to the 5th, u squared plus 1 squared, and then du. So it's going to look wildly different, correct? But that's okay. So u to the 5th, I'll save for a second. So I'll get u to the 4th plus 2u squared plus 1 du, 1/3 u to the 9th plus 2u to the 7th plus u to the 5th du, and then I'll add 1 to the exponent and taking the antiderivative, and we'll see, we'll get very different answers, but they're both the same. Come on, how come it's not erasing? Sometimes it's difficult. Sometimes it just doesn't want to erase. All right, it's not going to erase for me. All right, so I get 1/10 u to the 10th plus 2/8 u to the 8th plus 1/6 u to the 6 plus c. So I'll put the tangent back in for the u, and I'll put the 3x back in for the w.